Hi, I am Clifford Glenn Alicante, a first-year chemical engineering student. Today, we will be having a tutorial about geometric designs and patterns. For this tutorial, we will be talking about symmetry, rosette patterns, frieze patterns, and tessellations. First is symmetry. Something is symmetrical when it is the same on both sides. A shape has symmetry if a central dividing line, a mirror line, can be drawn on it to show that both sides of the shape are exactly the same. There are four types of symmetry: the rotational symmetry, reflection symmetry, translation symmetry, and glide reflection symmetry. Rotational symmetry occurs when a pattern that we can turn a pattern by some degree about a point and the pattern looks exactly the same. A great example for rotational symmetry is the starfish. Reflective symmetry occurs when a pattern can be folded across a mirror, so one half lies on top of the other. A reflection flips all the points in the plane over a line, which is called the mirror. An example of reflective symmetry is the shape of heart. Translation symmetry occurs only in patterns that cover a plane. This happens when you can move a copy of a pattern a specific distance in a specific direction, so that it lies exactly on the tip of the original pattern. A translation slides all the points in a plane the same distance in the same direction. For this example, the houses are translated with a specific distance and direction from each other. Glide reflection symmetry is much like translational symmetry. When you move a pattern a given distance in a given direction and then reflect it over a mirror line so that it lies exactly on top of the original pattern, that pattern has glide reflection symmetry. A glide reflection translates the plane and then reflects in across a mirror parallel to the direction of the translations. A great example for glide reflection symmetry is footprints. Second is the rosette patterns. A rosette pattern describes the possible symmetries of a flower or a pinwheel. The repetition aspects of a symmetry describes the petals around the stem. We have two types of rosette patterns: the cyclic and dihedral rosette pattern. Cyclic symmetry group has rotation symmetry only around a center point. If rotation has n order, the group is called C sub n. As for this example, the pattern has 12 order of rotation. It will be C sub 12. Dihedral symmetry group has rotation symmetry around a center point with reflection lines through the center point. If the rotation has n order, there will be n reflection lines and the group is called D sub n. For this example, we have 8 orders of reflection lines. The group is D sub 8. The difference between cyclic and dihedral rosette pattern is that dihedral has symmetrical in every order, which has reflection lines, while cyclic do not. An infinite strip with a repeating pattern is called a frieze pattern, or sometimes a border pattern or an infinite strip pattern. The term frieze is from architecture, where a frieze refers to a decorative carving or pattern that runs horizontally just below a roofline or ceiling. All frieze patterns have translation symmetry. A horizontal frieze pattern looks the same when slid to the left or right. A vertical frieze pattern looks the same when slipped up and down. And in general, any frieze pattern looks the same when slid along the line it is laid out upon. Some frieze patterns are also a combination of a translation and a reflection. This combination is called glide reflection symmetry. The names of symmetry groups that were standardized by the International Union of Crystallography, known as the UIC notation. These names all begin with P, followed by three characters. The first is M, if there is a vertical reflection, 1 if not. The second is M if there is a horizontal reflection, A if there is a glide reflection, and otherwise 1. The third is 2 if there is a 180 degrees rotation, 1 if not. There are 7 groups of freeze patterns. These are P111, which has only the translation symmetry, the P1M1, which has horizontal mirror symmetry, the PM11, which has vertical mirror symmetry, the PMM2, which has vertical and horizontal mirror symmetry, and 180 degrees of rotation, the P112, which has only 180 degrees of rotation, the P1A1, which has a glide reflection, and the PMA2, which has a vertical mirror system, glide symmetry, and 180 degrees of rotation. Lastly, the fourth, the tessellation. A tessellation or tiling is when we cover a surface with a pattern of flat shapes so that there are no overlaps or gaps. There are kinds of tessellations: the regular, semi-regular, and irregulars. A regular tessellation is a pattern made by repeating a regular polygon. There are only 3 regular tessellations, and these are tessellations of triangles, squares, and hexagons. A semi-regular tessellation is made of 2 or more regular polygons. The pattern at each vertex must be the same. For this example, the tessellation of 4 triangles and 1 hexagon. To name tessellations, we go around a vertex and write down how many sides each polygon has, in order, like 3.12.12, and always start at the polygon with the least number of sides, so 3.12.12, not 12.3.12. This time, you will be naming this tessellation. What do you think is the name of the tessellation? And that is all about the geometric designs and patterns. I hope you learned something. See you next time!